Now we're going to talk a little bit about perturbations. So here's a very simple schematic of the Earth, and so let's say this is Mercury and Mars. I'm sorry, the Sun in the middle, and Mercury and Mars and the Earth and some other planet. Now the orbits around the Sun are fairly stable. We'll pass around the Sun. We'll pass around the same orbit each time. But what happens is that the planets themselves actually attract each other, right? All the mass in the universe attracts all the other mass. So when they get close enough, they can actually feel the force of gravity attracting them. So if these two are passing close enough together, it would slightly change what their path is. Okay? So as they get closer together, the actual attraction from the other one is more pronounced. Okay? Now, what this does is create small perturbations in the orbits, so that the orbits around the Sun are not exactly elliptical. Okay? And this is one of the things that helped bring Newton to believe in universal gravitation, that the planets themselves were attracting each other. Now, if you take careful measurements of the orbits, you can actually figure out where the other planets are. So astronomers used careful measurements of Uranus's orbit and looked at the perturbations in it, and they predicted where Neptune should be. And then they pointed their telescopes there. They found Neptune, a new planet. And if you take a look at Neptune's orbit, they looked at the perturbations in Neptune's orbit and predicted that there should be another orbit, or another planet out there. And, of course, there was, and that's now called Pluto. Whether it's a planet or not is up for debate. Now going back to our flash demo, here we have a sun-planet comet again, and this time I'm going to let it run a little longer, and so we can see the interaction between this planet that's orbiting the Sun and the comet that's orbiting the Sun. Now when they get close to each other, they start to perturb their orbits. So here they came close to each other and it slowed this one down. And I think on the next pass they will come close to each other again. And it actually made it crash into the Sun here. Okay? Okay, let's do another example of the objects interacting with each other, and this one is a major interaction, not just a perturbation. It's called a slingshot, and you may have heard that when we send out some space probe to one of the far-off planets, we use the slingshot effect to get them out there. And this sort of shows that. So here's our body orbiting, and it's going to use the other planet to slingshot it even farther out. It gets closer, and then it pulls it off into a much larger orbit. Along the same lines, we have the double slingshot, which now our particle is going to use one to slingshot it to the other to slingshot it even farther. So we got the slingshot there, and this one, slingshot around the other one, and now it's on a much different trajectory. Now we'll take a little time to talk about Newton's synthesis. And obviously Newton was a big guy in physics, but as we look through what he did was actually bring a lot of his own, he brought his own stuff, but he brought in a lot of other theories, okay? And he brought them together to form the complete description of motion. So it was not only his own ideas, but a lot of other people's ideas that brought this all together. Now, in him doing that, he actually caused a great ripple in philosophy with deterministic philosophy. And this has to do with like cause and effect, and a deterministic worldview, like using Newton's laws. We know that if we know the initial conditions of an object, we know what will happen to it later on, at any point later on. So if I throw a ball, if I know what angle I threw it at, what velocity it was going, I can tell you where it's going to be later on. Okay? Or if I knew its point in some point in its flight, I could tell you where it originated from. Okay? So this causes a problem in philosophy, because if simple particles do that, then do people do that? Is our fate fixed? Because everything's deterministic. Once it's started in motion, everything that's going to happen is already known, will happen. Now, these days we don't really follow deterministic philosophy, and part of that was actually because of quantum mechanics. And quantum mechanics explicitly states that we can't actually know how things are going to turn out exactly. That there's this little wiggle room where things aren't exactly deterministic. Okay? Which, again, changed philosophy quite a bit.